Voyager 1 was once thought to be lost, but a new signal from deep space has ended the silence. The longest operating scientific probe is transmitting once again. After a complete system failure in 2022 and additional setbacks in 2023, Voyager 1 is back in action. What lies ahead for this pioneering spacecraft? Currently traveling through a region of interstellar space that fascinates scientists, Voyager 1 continues to send back intriguing data about the vast, mysterious expanse between the stars. The interstellar medium remains one of the universe's greatest enigmas. Before Voyager 1 crossed into this uncharted territory, our understanding of what exists beyond the solar system was extremely limited. If we're to truly grasp the nature of the cosmos, it's this very frontier we must explore. What is the vast and mysterious emptiness that fills most of the universe? What conditions exist in this seemingly silent void, and could there be unknown forces or phenomena at play? To explore these questions, NASA's Voyager 1 and its twin, Voyager 2, have become essential tools for astrophysics, pioneering humanity's first direct exploration of the interstellar medium. Launched more than 45 years ago, these probes have traveled farther than any other human-made objects, reaching regions of space where no scientific instruments had ever ventured. Along their journey of billions of kilometers, the Voyagers have continuously transmitted valuable data from the outer reaches of our solar system and beyond. The information they've gathered over decades is immense, so vast, in fact, that it may take generations of scientists to fully interpret it. Naturally, NASA is determined to keep these legendary spacecraft operational for as long as possible. Yet in recent years, concerns about the mission's longevity have grown. In 2021, for example, Voyager 1 began transmitting garbled, indecipherable data, leading scientists to fear that contact with the probe had been lost. That could have spelled trouble, as the spacecraft's batteries need to last into the early 2030s to transmit even basic data from the interstellar medium. After more than 45 years of faithful operation, Voyager 1 had started sending back garbled, seemingly encrypted signals. This sparked wild speculation among UFO enthusiasts, with some suggesting aliens might have interfered with the probe. But that theory didn't hold up. A Deep Space Network technician, part of the team that maintains communication with Voyager 1 and 2, managed to decode the scrambled data and confirmed there was no extraterrestrial involvement. The issue was traced to a failed communication unit on board. NASA engineers fixed the problem, and Voyager 1 resumed its remarkable journey through deep space. The first real images of Jupiter, it was pure magic when the first images of the planets Jupiter and Saturn flickered across our screens in the 1980s. Never before had humans seen the gas giants of our solar system so clearly. If we think back to that time, we have to remember that until the 70s, humans knew very little about what lay beyond Saturn. The first probes, such as the Mariners, delivered very blurry or very gray images of the planets in the immediate vicinity of Earth. Before the era of space photography, our understanding of planets like Uranus and Neptune was limited to sketches and artistic interpretations. The visual exploration of our solar system began just around 70 years ago, and for over 45 of those years, the Voyager probes have played a central role. It's surprising to many that we only got our first real image of Pluto in 2015. Prior to the arrival of the New Horizons probe, no telescope or spacecraft had been able to capture a clear view of this distant world beyond Neptune. Today, we're surrounded by stunning, full-color images from the far reaches of the cosmos. We've witnessed vibrant stellar nebulae, exquisitely shaped galaxies, and even managed to photograph mysterious black holes. But in the 1980s, the landscape was entirely different. This was before the launch of Hubble, the first space telescope that revealed the breathtaking diversity of the universe. Back then, millions of viewers were captivated just by the first detailed images of Jupiter's swirling clouds and massive storm bands. Before the Voyager spacecraft ever approached, Jupiter's marbled surface could already be seen through powerful telescopes. But it wasn't until the Voyager missions that finer details, like the iconic Great Red Spot, came into view, revealing just how chaotic and dynamic the planet's atmosphere truly is. A few years later, Saturn was unveiled in stunning detail, dazzling humanity for the first time. The planet, known for its eerie silence, radiated beauty through its spectacular ring system. Thanks to Voyager, we were also able to observe the incredible variety and complexity of those rings. After completing its main mission, Voyager 1 charted a course toward the outer edge of the solar system. Meanwhile, Voyager 2 performed a gravity assist maneuver at Saturn and continued on to Uranus and Neptune. On January 24, 1986, it sent back its first data from Uranus, captured from a distance of about 81,500 kilometers. Among its discoveries were the confirmation of Uranus's extreme axial tilt and the presence of a strangely skewed, offset magnetic field, unlike anything seen before. Another major highlight was Voyager 2's exploration of Miranda, one of Uranus's moons, showcasing a rugged landscape filled with deep canyons, towering cliffs, and intricate terraces. During its journey through the Uranian system, the spacecraft also discovered 10 previously unknown moons and 2 faint rings. Surprisingly, Uranus's atmosphere appeared unusually calm, with minimal signs of weather activity. Fast forward 3.5 years to August 25, 1989, Voyager 2 reached Neptune, revealing a stark contrast. Neptune turned out to be a highly dynamic, storm-ridden world. Among its dramatic features was a massive storm system dubbed the Great Dark Spot. Researchers were astonished by the planet's extreme wind speeds, exceeding 2,000 kilometers per hour, some of the fastest in the entire solar system. Voyager 2 also detected a tilted, offset magnetic field and uncovered 6 new moons, including Triton, Neptune's most well-known moon, which intriguingly orbits in the opposite direction of the planet's rotation. Voyager 2 revealed Triton's thin nitrogen atmosphere and captured the first images hinting at active ice volcanoes on the moon. One of its final major discoveries in the outer solar system was a photo showing Neptune's delicate ring system. This groundbreaking mission to Uranus and Neptune dramatically transformed our understanding of these remote ice giants. What once appeared as faint points of light through a telescope were unveiled as dynamic, intricate planetary systems, complete with active atmospheres and a variety of moons. The excitement and wonder among scientists were beyond words, and many of the images from the mission have since reached iconic status. With its primary mission complete, Voyager 2 continued on a new journey toward interstellar space. The adventure didn't end, it evolved. Meanwhile, Voyager 1 began sending back data that strongly suggested it was nearing the very edge of our solar system, a moment that surely sent shivers down the spines of everyone following its journey. Our Sun surrounds itself and all the planets with a protective bubble of particles and plasma known as the heliosphere. Before recent discoveries, scientists weren't certain how the boundary of this heliosphere was shaped. Models had predicted a gradual, gentle transition from the Sun's influence to the vastness of open space, similar to waves softly breaking on a shore. But in 2012, Voyager 1 brought a surprising revelation. It crossed the edge of the solar system with a sudden, sharp jolt. This indicated that the Sun's outer boundary acts more like a solid wall than a smooth gradient. Voyager 2 later confirmed these findings a few months afterward. Since then, our understanding of how the solar sphere interacts with interstellar space has evolved significantly. It's important to remember that our solar system isn't stationary. It races through space at incredible speeds while orbiting the center of our galaxy. As the Sun and its planets move, dynamic interactions take place between the heliosphere and the surrounding space. This information is invaluable to science, offering insights into the forces and processes shaping galaxies, and explaining how such remarkable order is maintained in the cosmos.